we're going to be talking about continuous delivery an awful lot today. You've got the book on your table. The book, you are free to take the book with you, by the way. Please do. We've got lots of copies. The book talks a lot about the technical how you do continuous delivery. I think you're going to hear a lot today from people who've gone through that journey themselves. And everybody's journey is slightly different. But to really give you some sort of grounding in what it is, we felt we should do at least a brief introduction as to what continuous delivery is and where it comes from. As Nick mentioned, I'm the practice lead for the continuous delivery practice in Europe. That means as well as working with clients, helping them adopt continuous delivery, I'm also spending a lot of my time focusing on cloud and DevOps technology, as these sort of these emerging fields are a significant enabler in making continuous delivery possible. But to really understand what continuous delivery is, and we need to know where it came from and what problems it's trying to solve. And so we're going to need to go back a few years to think about what the default way of doing software development was many years ago. And like every new profession out there, we want to compare ourselves to somebody, compare ourselves to a successful profession, somebody that's very good at doing things, that makes big, sturdy things that don't fall over, like a lot of our software does. And so we like comparing ourselves to engineering. I myself did a software engineering degree. We like to compare ourselves to engineering because bridges, on the whole, don't fall down. Buildings don't tend to collapse. So we like those aspects of what engineering is about. But let's think about how a bridge gets built. A surveying team turns up. They look at this bank. They look at the bank over there. They take some measurements. It's 500 meters. They think about the traffic that's going to go over that bridge. They think about the materials available to them to construct it. And they spend lots of time thinking. And then they spend lots of time coming up with blueprints. And then they build the bridge. And then there's a bit of cleaning up afterwards. My builder calls it snagging. There's always more than you'd like. But nonetheless, and then the bridge is in use. Fantastic. And so, of course, what we did was we took those ideas and brought them into software. So we spent a lot of time thinking about the problem and writing a specification for what the problem is we have and how we're going to solve it. We then spent an awful long time writing the code, building the bridge, where we would implement what the specification said. There would then be a period of snagging or testing, as we called it, that went on longer than everyone would like. And then finally, we get to use the software. Now, this process takes a while, but that's OK because building bridges takes a while, and so do building houses and skyscrapers and all these other sorts of things that we would like to think are big and heavyweight and just work. So it would take us typically months, if not years, to get our software out. And we call this thing waterfall. There's a problem, of course, with this approach. Writing software is not like building a bridge. It's not really like engineering in the classic sense of the word. In fact, if building a bridge was like writing software, halfway through building the bridge, you'd find that the furthest bank had moved out another 500 meters, that you had to go from transporting passengers, and now you've got to add a rail deck. Oh, and by the way, you can't use steel anymore. You're only allowed to use wood. The reality is we write software for a changing market. We write software to support business goals. These things change a lot more than the physical constraints of the real world. And ultimately, we want to embrace change. We want people to change their minds. Our businesses change directions. As Cindy showed us earlier, just looking at the statistics about how long companies remain in the S&P index, these things are shifting all the time. And the idea that our software can't accommodate that change really wasn't good enough. And so a group of people who were looking at more iterative ways of developing got together and came up with the Agile Manifesto. So Jim's one of the signatories. And this was an attempt to say, well, really, the way we develop our software needs to embrace the fact that we need to be able to change. We need to be able to change direction. We need to be able to involve the customer more and take their feedback on board and integrate them more as part of the process. These famous 4 statements on the website, it's definitely worth a read. Now, that led to a shift in how many of us do development. And I'd say probably in the last 5 years, Agile's well and truly gone mainstream. And what this basically involved was us taking our big, heavy process and breaking it up into lots of iterations. Scrum calls them sprints. Most of the other Agile methods, they refer to them as iterations. And with each iteration representing a small amount of planning, so the specification writing, some development and test, and then there's some showcase, showing it maybe to a customer proxy, and this idea that you're getting feedback earlier that what you're writing matches what you're trying to achieve. Also getting some feedback that your software actually works. Around this time, we also developed engineering practices that helped us understand, is our software ready? Or at least some value of, is it ready? Again, trying to bring that feedback forward. Are we going in the right direction? And continuous integration is this process by which a developer can check in some code. There's some verification on check-in that that code kind of works. Okay, I've checked my code in and yes, it's green. And then another developer comes along and he checks in some code and all that's red. And this was a huge improvement for many organizations whereby they would maybe only start actually making sure the code compiles at the end of every month or so and wouldn't bother even running any tests until 6 months in. And these things gave us fast feedback. So we're getting this idea now that Agile allowed engineers, developers, to get fast feedback about the quality of our code. But this idea of breaking up our work into these iterations gave feedback for our portfolio management. Are we on track to deliver? It gave us a progress bar. We're using velocity or in Kanban just by card counting. All of these methods allowed us to say, are we on track? And progress bars are great things. They help us understand how long is it going to be before I can do something, maybe cross the road. They also allow us to take alternative actions sometimes. So if a progress bar is taking way too long, if it's taking way too long to get somewhere, I can hit the cancel button. The value for a lot of people from Agile came about because they could pull the plug on a project way earlier than they could with waterfall. You might spend 18 months developing something only to find that no one wants it, and then you've waited 18 months for money. In Agile, many people adopted it and found 3 months in that the idea was stupid and it was going to cost them too much. And yes, that's 3 months worth of money that's gone, but it's better than 18 months of money. Some progress bars aren't great. This one says the progress bar status may not update till this finishes, which is not a great progress bar. I'm sure some of you have had portfolio management issues like that. But this is great, right? So we know we get this sense of done, and we can carry out alternative action. We can report up in ways we never could before, which is fantastic stuff. There is a problem, though, right? So if these are my iterations and I'm done at the end, am I really done? Well, yes and no. Because, of course, what actually happens is at the end of this process, I have things like UAT. I have to do a bit of UAT and probably SIT. Might need to do some SIT. I'm not sure what SIT is, but we have to do some of it. There's some perf testing. It's always best to leave the perf testing till the end. Must do that because then you've got lots of time to incorporate. Anyway, it's important it's at the end. There's also some security pen testing. I like building security in at the end as well. It's best as an afterthought. And just this unidentifiable operational overhead that just seems to happen at the end of when we're done. So we have this idea that when most organizations, when they adopted Agile, they managed to fix issues within the development team, and they improved the situation. We're significantly better off than we were, but there are still challenges. Done not necessarily meaning done, being one of them. We call this stuff at the end often the last mile. And a lot of what continuous delivery is about is trying to address some of the things that need to happen here. Now, a lot of this needs to get done. It's just about when and where we do it. And the problem is that for many people who adopted Agile, they didn't necessarily improve their time to market. They allowed them to produce maybe the software they could produce in the past more efficiently. They went in the wrong direction less. They may have been able to can projects that otherwise would have taken them a lot longer to can before, and those sorts of things that were better off. But ultimately, we weren't necessarily releasing our software more frequently. The Scrum book says after your sprint, you should release the software into production. I've yet to find a Scrum shop that actually does that religiously. So there are challenges there around how frequently we can get our software out. Why is that the case? Well, partly it's the case that this is the team that was impacted most by the last 10 years of Agile, the development team. Developers, project managers, BAs, QAs. These are the guys, those are the people on the Agile manifesto, right? And that's where the impact of Agile has been. Now, if you think about at least just one example of a stakeholder group in the average IT organization that hasn't really been impacted by that change, and it's the operations team. And that's just one example. There are plenty of others. And here we have two different groups within an organization incentivized along different lines. The development team, incentivized in the past about delivering software, now incentivized maybe by velocity. And I think Jim's going to talk about the tyranny of measurement later on. And an operations team, classically incentivized by keeping the light switched on. Business continuity. Change is the enemy. No one talks to operations unless they're in trouble, or they screwed up, right? If something goes wrong, the operations team gets it in the neck. When everything's okay, they don't even know you're there. And, Agile clearly happens here. It doesn't happen anywhere else. So you have these barriers within organizations that haven't been broken down by the traditional adoption of Agile development methods. And you have, obviously, lots of different teams that within an organization work in lots of different ways. And organizations group like operations have to cut across all of those. There's also an issue that we really have with Agile, most of the transformation was in terms of processes. The technology, the tooling, was actually a very small part of making Agile work. But many of those challenges I outlined, the processes that happen once dev is complete, they do actually need technology and tools to help change the way we work in those areas. And so going to many of these teams and asking them to work in a different way was a bit unfair because their toolbox was empty. There's a second page to the Agile manifesto on the link. There's a link, you can click on it. I don't know how many people actually click on the link, but there is a link there. And it takes you to the principles behind the Agile manifesto. And this is the top one. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. So the guys who wrote the manifesto were thinking of getting this software out into the hands of their developers. That's what they wanted to do. That's always the goal. Which didn't happen as easily in many of our organizations because of those constraints. But now you know where the term continuous delivery comes from. So Jez and David can't copyright that one. There have been many definitions, an attempt to sort of synthesize down what continuous delivery is. There's a definition that Jez gave recently that I quite like, and the one I tend to use with people. And that's that continuous delivery is about making sure software is always deployable throughout its life cycle to maximize feedback. So we're going to break that down a bit. Feedback. What do we mean by feedback? Well, maybe the first thing to think about is what happens to our software. I sit at my desktop machine, I'm writing my code. I still get to write some code when I'm not waving my arms around. My tests pass. I do a bit of manual testing. It feels okay. I've got some confidence the system is going to work. It then moves into a test phase, and I've got a QA who's there running maybe some automated regression tests, maybe some usability testing. I'm getting more confidence. You know when my confidence is really high that my software works? When it's in production, it's actually working. So we have this idea that throughout the life cycle of our software, the closer we get to production, we're trying to look for more confidence that what we have created actually works. The problem we have is that a lot of the time, when we're writing features, it's not just do they functionally work based on what the specification says, it's do they have the impact we hope they would have. I mean, you can think of every feature, every story you implement as effectively an untested hypothesis. I am writing this feature because I believe it's what people want. Do I know? I kind of don't know until someone's actually using it. There may not be any bugs in the classic sense of the word. But until it's released, it's just inventory. Inventory as waste is a commonly understood concept from things like retail, where you're concerned about the cost of storing your goods. It costs you money to have warehouse space. It costs you money to have code that's being maintained. Not in terms of storing it on spinning platters, but in terms of the maintenance overhead that your team has of maintaining large code bases. Now, that's okay when you're getting a return on it, but if that software isn't being used, you are paying to maintain code. You don't know if it works even necessarily against what it should do, and you don't even necessarily know if it does what you hope it will do until you actually make that leap and put it out there. And the problem is that for many of us, we might wait 6 months, 12 months, 18 months before getting it out, and it feels like a big bungee jump without necessarily a cord sometimes, to find out if people actually want this to work. Does it do what I think it should do? And so you've got to think about the software you are writing as inventory in the classic sense of the word, because until it's out there, you're getting zero return, and if anything, it is costing you money. Always deployable. Jay says always deployable. Do all of these things make our software always deployable? Now, they may make it easier to do. It might not stop me deploying maybe into a development environment. But many of these aspects can stop me deploying maybe into integrated QA environments, for example, where I might get better feedback. Does my software work? So there's this idea that you're trying to make it very easy to deploy across the life cycles. We need to break these barriers down. And one of the things that's happened during us looking at this is trying to take some of these tasks and move them more in line with our day-to-day check-in cycles. Jez and Dave talk about the concept of finding the pain and bringing it forward. So this stuff is painful, and often we react to pain by deferring it, which means that we do it less frequently, which means when we come to do it, there's more of it to do. Whereas when you have to bring the pain forward, you have to make it hurt less. Otherwise, I think you're a masochist. And I don't think any of us here are masochists, at least as far as software development is concerned. So taking the concept of continuous integration and extending that, trying to pull some of these things back, gives us this idea of the sort of the build pipeline. The idea now that when I check my software, and I'm not just doing some unit testing, some performance testing, but I'm now starting to allow deployment, for example, into showcase environments. So tools like Go, for example, will allow you to actually specify a build pipeline that can still encompass manual steps. So I could manually say right now that my build has passed the performance test. OK, I'm going to take the most recent build. Let's deploy that into my showcase environment. Are we happy? If we are happy, now we can make the next step and maybe make that release into deployment. So trying to extend those ideas, bringing those things at the end, bringing them forward to allow us to more rapidly deploy. And if you think about the value of the feedback you get that we talked about earlier, the problem when we defer all these things to the end is that the cost of a deployment mirrors this. And really, with continuous delivery, we're trying to take these things, get them out of the way so that we can flatten that cost of release. Why is this happening now? Why weren't we doing this 10 years ago? Clearly, Jim's just been sitting around since he signed that manifesto and not doing any hard work. Well, the reality is there was some of the constraints that we talked about earlier. Experience. It's taken us a long time for Agile to be mainstream, and yet still the majority of the industry does not do Agile. But it's sort of crossed the chasm, although we're not quite doing it, and even then it's had a limited impact. Cloud computing is actually starting to have a significant impact on this. Many of the impediments we face in the last mile are around things like, can I provision an environment? 2 or 3 years ago, our first clients using Amazon were not interested in production environments. But we were working with them and said, well, we need a continuous integration environment. We need to performance test the software early. And these things took months. One client I worked with, it took 9 months and 11 separate teams to provision virtual machines for us. Now, in that environment, I would just say, OK, I'm going to maybe bring up my performance test environment instead in the cloud, allowing me to do things more in line. So it's an enabling technology. Automated testing, we have got significantly better at this. Although this has been concentrated in the world of, say, web development, there's a lot of good thinking going on outside of that. If you look at things like Frank, which is an iOS testing framework that we open sourced, now for mobile, you can do automated testing. In the past, one of the huge constraints was the fact that your software maybe had to pass a manual test cycle that was run by 500 people sitting there running through a script. They never really got to the end of the script, but you'd have a 3-month, okay, we'll just do a manual test for 3 months, and they'll probably catch things. You can now run 3 months worth of testing in an automatic, repeatable fashion in minutes on every check-in, taking a lot of the need for the people acting as computers out of that last mile activity. At DevOps, I talked about that interface between the development and the operations world. This has come partly from developers being given all these machines on the cloud and suddenly realizing, well, what do I do with this now? What's the operational space? How do I work with this stuff? But it's also coming from the operational side where people are looking at Agile and thinking, what does Agile mean for us? And so you've got people now looking at techniques, thought processes about how do I break down barriers? I mean, because ultimately the company should be about delivering software. So how do we align ourselves so that we're all aligned along the same goals? Out of this movement have come tools like Puppet and Chef, which have significantly changed the game in how we manage our infrastructure. I'd say the majority of our clients are either actively using Puppet or Chef, or tools very like it, or they're looking to adopt them. These are tools that are open source tools, although be it supported by commercial companies, that are really undermining the traditional operations space, which is dominated by vendors with UI-based tools. Puppet and Chef are tools that allow me to automatically and repeatably configure environments for use, for me to deploy my software on. It solves many of the issues around visibility and repeatability. It doesn't replace the need for operations teams. It just means our operations teams need to be better. But it replaces documentation with software that works, that can be checked in and tested. So all the way back to the Agile Manifesto, working software over comprehensive documentation. Agile Analytics is probably the newest thing that's coming out. Remember what Jez said, fast feedback. The best feedback of all I said was in production, but what does that mean? Probably your traditional Agile Analytics story is, well, I've got my website up and I've got my Omniture clicks. So I'm going to send my Omniture clicks off to my Cognos cube, and in 2 days from now, I'll find out what happened on my website. And if I want to ask a different question, I'll ask the nice consultant who I've got in who understands how the data cube works to change my report, and eventually I'll get my report out. Again, this is a vendor-heavy space where people are not wanting to deploy their software rapidly. That was kind of okay. Now when you're looking at people that want to experiment more to get that quality of feedback, they're starting to look beyond what's in the standard vendor space. You're seeing work from open source stuff is starting to emerge in this area. I think the analytics side is kind of a watch this space, but it's getting very, very interesting. And all this is building towards this vision where you should be able to know what's happening in your production system now, real-time user telemetry, rather than what happened 2 days ago. A knowledge about what's going to happen when I deploy, what is ready to go, that known quality that comes from having a deployment pipeline, knowing that check-in passes all my quality gates and here's what's in it, and the ability to release on demand. This is kind of where many organizations adopting CD are trying to move towards. I've used some photographs in this, which I have to mention because they're Creative Commons licensed, and I'm a good photographer. And I'll be talking after the break about how you can look towards adopting continuous delivery in your own organizations. I do have time for some questions. So the question was, why do organizations think it's news that you're doing this automation part way, then you sort of stop? I think we sometimes give ourselves a bit of a hard time. I mentioned at the beginning we compare ourselves with other industries that have been around. And people have been building bridges for what, 6,000 years, 10,000, 15,000 years? We've been doing this for 70 years. We're learning a lot. A lot of it's about showing it's possible. How many people could conceive of what we can do now 5 years ago? I couldn't. So I think it's partly about seeing it done and believing it's possible. And so I think we can beat our people up too much. I think also what we're seeing is organizations that have no choice but to innovate to succeed is part of this. We have the benefit of learning a lot from the web operations space, the startup space, where that was how they succeeded. They had to find a way to succeed, and by definition, they're the people we hear about because the ones that didn't do that didn't succeed. And now we get to learn from them. Whereas I think within the enterprise world, no CIOs beating up their people saying, why aren't you doing infrastructure automation like these guys at Etsy and Flickr? Because no one else they're competing against is doing it yet. And that's the change that's happening now. As this stuff comes out from those spaces and it moves more into the mainstream, you're going to get more competition from other organizations that are adopting these automation practices that can turn around new features more quickly. Any other question? Yeah, so the question was, I've got a big data center, I need to build out these big computation centers. How do I introduce Agile? We will talk a bit about that later on, but I think the cloud thing is interesting. Some people are questioning, do I need a big data center? It takes a bit longer, right? Because ultimately, within the software development world, we are manipulating bits and bytes rather than physical things. Physical things like racks and cabling and those things, they have a lead time associated with them. I think what people are starting to do is say, okay, I need a big investment potentially in my own data center, but what I need to do is make more use of that data center. Seeing much more viable private cloud offerings now that let you go beyond just say what simple virtualization does, into making more use of the infrastructure they have got and becoming more like a commodity service within their own organizations. There's also an aspect from, if you think about what people traditionally think of as big, really big systems, that if you're going to build a new clearance system, it's going to take you 3 years. There's also a whole lot of thinking that needs to be done about how we design our systems in the first place from the ground up to allow for delivering them in a more incremental fashion. I hope you haven't think I've fobbed you off, but hopefully I'll cover some of that stuff off a bit later on, and if I haven't, we can talk maybe at lunchtime.